Hey folks, welcome back. Mr. Johnson again, and today we're going to be discussing solving systems with three variables. Three, yeah, definitely more than two, and definitely going to take a little more energy and focus on this. So for those of you that sometimes need to be warned, hey, this is going to be a good topic to take notes, this is that warning. This is going to be one that you may want to play back a couple times and make sure you thoroughly get, because this can be a little bit more challenging than the two variable situation. I also need to emphasize to you, sometimes these are going to take a full piece of paper to actually solve these out. So don't try and do it in like a quarter sheet of paper. You're going to need more room than that. We're going to combine together the things that we've been using in the past. We'll be using elimination, and we're going to be using substitution, but not necessarily guaranteed any particular thing there. I also want to point out to you that yes, you do have Math Excel assignment that you need to get done for this. So please make sure you get that done in a timely manner. So let's take a look at an example. Now this is technically a warm-up, and what I would like you to do is please look at this figure, and you have all the information you need to be able to solve for the weights of box A, box B, and box C. And what I would like you to do is take this, pause the video, and see if you can figure out how much each one is. And I'll give you guys a couple seconds. And you've paused it, and you're now waiting because you don't want to be looking at me. Good. All right. So what do I need to tell you? Well, I can tell you that A is going to be 2, B is going to be 4, and C is going to be 6. Now, how did I pull that out? Well, some of you might have done it via just old school guess and check, and you took a couple values and you kept doing things until they worked, which is fine as long as the numbers are small, like we've got here. But what happens if they're a little bit larger? Well, how would you go about doing that? Is there a way to make it systematic so you can solve it on a regular basis? Well, because this is a balance in this situation here, I can say that these two values are equal. So I'm going to say that 2A has to equal B. And over here I can say that C is equal to 3A. And once again, I can say B plus C is equal to 10. Now that looks very impressive and unfortunately a little bit intimidating, because now I have three equations and I'm using, well, three different variables, but not all of them at the same time. What I can do though is I am now going to take this whole B plus C thing from over in here, and I'm going to substitute the values in. See, B I know is going to be equal to 2A, so let me substitute that in. And over here I say that C equals 3A, and I'm going to substitute that in. So I'm now looking at 2A plus 3A is going to get me 10, or 5A equals 10, and therefore, hopefully nobody's going to be surprised when I say that A equals 2. Well, that part's easy. And then all I need to do is say, well, if A is 2, 2 times 2 is going to get me the 4. And then 3 times 2 is going to get me the 6, and ta-da, we're done. That's not bad. Unfortunately, the problems we're going to be doing are going to be a little bit more challenging. So on each of these cases, I am going to ask you to, first off, freeze the screen once you've seen the equation, to copy it down, and then you're going to want to start taking notes. And again, take down some of the strategies I'm doing, because I'm not doing it to try and listen to myself talk. It might be beneficial to you. So solving the system of equations with three variables. Here is my system. Pause the screen and see where you can get to on this. Okay. Now, right now, I'm going to give you step number 1. You want to get rid of one variable. I have no idea why I did that. Okay. Variable. Well, okay. Unfortunately, my handwriting using that particular thing is not working that well. Get rid of one variable. Now, you don't always want to get rid of the same variable. For some reason, some students think, oh, I always have to get rid of x, or y, or z, or whatever it is. I'm literally going to vary what variable I'm getting rid of based off of the situation. So let's see what I can do on this first one. Let's say that I decide, and there really is no reason for this on this one, that I am going to eliminate y. Now, how am I going to go about doing this? Well, I can eliminate y by multiplying this equation through by -1. And I'm going to combine that with that second equation. So here's my second equation. 2x plus y plus 3z equals 7. And then I'm going to multiply that second equation through by -1. So I'm now looking at a -x minus y minus 2z equals a -3. Okay, and I can now say 2x minus an x is going to get me 1x. Positive y and negative y cancel each other out. I'm now looking at positive 3z and negative 2z, which is going to get me a positive 1z, and there we go. So now I have an equation where I've eliminated y. So far, so good. Next, I'm going to try and do the exact same thing, except with another pair of equations. I've already used my first pair of equations, so I need to use a different pair of equations. Which equations do you have to use? Just as long as it's a different pair of equations to eliminate the y, it really doesn't matter. So I'm just going to take these two down here. I'm going to combine these two together. And what do I need to do to try and make it so that I'm going to eliminate my y term? Well, if I multiply this one through by 2, I'm going to get 4x plus 2y plus 6z equals 14. And then I'm just going to recopy this third equation and say that's going to be a minus x minus 2y plus z equals 10. Now again, my strategy being the exact same thing that I did with elimination. You want to set things up so that, like I did here, you get opposites of each other. Here, I've set them up and they're opposites of each other. So there's my overall strategy. I've got myself set. Let me see what I can do about eliminating things. So I'm now looking at 3x plus 7z, 3x plus 7z equals 24. Now, hopefully people are relatively comfortable with that. And I now have a second equation that I can combine together with my first equation, and I just have to decide, am I going to use elimination? Am I going to use substitution? What am I going to do here? Now, of course, it doesn't matter because it works either way. But personally, I look at this and I can immediately say that looking at this equation over here in blue, all I have to do is subtract an x from both sides. And now I've isolated a z, and that value for z I can substitute into this equation here. So I'm now looking at 3x plus 7, but instead of putting the z there, I'm just going to put the 4 minus x that I solved for there. And from this point, it's just going to be a matter of a little bit of algebra. And again, if you need to stop and replay this, feel free. Let's see, 7 times 4 is 28, and 7 times negative x. So negative 7x equals 24. And so let me see what I can do now. I can combine 3x and negative 7x to give me a negative 4x. And then I need to subtract 28 from both sides so I can get things together there. So I'm now looking at a negative 4 there. That looks pretty nice. I'm looking at an x value of 1. So far, so good. but kind of like what we had to do with the other systems, we've got multiple variables we need to solve for. So the next thing I'm going to do is I'm going to try and find a nice equation to solve this in for. I'm hoping that people are probably already saying that might be a good spot. And so I can say that that's going to get me that z equals 4 minus the 1 down there. So I'm going to be looking at z equals 3. Okay, so now we've got z equals 3. So I've got x and I've got z. It's at this point that you just have to decide, okay, which of these original equations do you want to use to solve for your y? Now again, I'm going to choose one that probably will make my life as easy as possible. I'm going to get that by hopefully not having to multiply too much. So I'm going to say, let me use that equation there. So let's recopy it and say I'm looking at x plus y plus 2z equals 3. And now I'm just going to substitute values in. Instead of x, I'm going to write 1. Whoops. No idea why I did that. Okay. 1 plus y plus 2 times 3 equals 3 there. So that's going to get me y plus 2 times 3 is 6, 6 plus 1 is 7, and 7 is going to get me a y value of -4. And so now I've got all 3 of my variables taken care of. The last step I need to do is I need to take a quick second and I'm going to write down my answers for my variables as what is called an ordered triple. X, y, and z. And there you go. There is your answer. Okay, going once, going twice. Then we're moving on. Next up, I've got a second equation. Please take a second, copy things down, and let's see what we can do about solving it. Okay, and now we're going to dig in and we're going to make comments and say, again, first step is always, as much as possible, which variable looks like it's going to be the easiest one to get rid of. You'll forgive me for pointing out the obvious, but guys, I'm really hoping that everybody recognizes my z's right there are prime for picking. All we're going to need to do is combine things together and I can eliminate z 2 times. So let's get started on my first one. I'm going to say let's get going on this. And let me eliminate this by saying in the first case, I'm going to take my first equation with my second equation. So I'm going to say 2x minus y plus z equals 4. And I'm going to add together the second equation. So x plus 3y minus z equals 11. And let me just add straight down. I'm looking at 3x plus 2y equals 15. Cool. Got a new equation with just the 2 variables. Let me see what I can do about coming up with the next one here. Let's go here. And it looks like if I combine together this equation with this equation, since the z's are already opposite signs of each other, they should cancel out really nicely. So let's do that here. 2x minus y plus z equals 4. And then 4x plus y minus z equals 14. And we're going to add down and we get 6x. My y's cancel, and awesome! My z's canceled too. Oh, that's even better, because sometimes we can get ourselves down to not just 2 variables, but 1. Oh, that is awesome news. So now we just divide both sides through by 3, and I get x equals 3. Okay, very nice. Let's move on. Next step is going to be, well, since we've already got one of the equations and we've got our solution for one of the variables, next we're going to start plugging things in until we can find some answers. So I'm going to substitute this value in for 3, and that's going to get me, let's change colors here, 3 times 3 plus 2y equals 15. Well, 3 times 3 is 9. 9 plus 2y equals my 15. And now I'm going to subtract 9 from both sides. I'm looking at 2y equals 6, so therefore y equals 3. Fabulous. I've got x. I've got y. What do I need to do to solve for z? I just need to pick an equation and substitute it in. And I don't know, it really doesn't matter. How about I take this equation here and substitute it into that one? So let me get started. I'm looking at 2x minus y plus z equals 4. And I'm going to substitute in the values that I've got. So I know that x is 3, so it's going to be 2 times 3. And down here, I've got that y is 3, so minus 3 plus z equals a 4. Okay, 6 minus 3 plus z equals 4. All right, so 3 plus z equals 4, and z equals 1. Okay, well, that's not too bad. So 3, 3, 1, all set. Written as an ordered triple, and we're good to go. Okay, let's do another example. If you need to take a break, take a break. Copy this down. They're going to start to look a little bit different than some of the other ones, but that's okay. Give it a couple seconds. Copy it down, and we'll see where we can get to on this. Okay, and I'm back, and I'm going to say, well, which variable do I want to get rid of? In this case, I'm actually going to say I've already gotten rid of a variable here, and I've gotten rid of a variable here. It's just a case of which way do I want to go. I'm just going to be lazy. I'm going to say, well, the first one has already gotten rid of the z, so I've already got one equation where I have just the two variables. That's good news. Now I need to combine together two of my other equations, which would be this one here and that one there, in such a way that I can get rid of my z in that case. Again, using the information that we've had from solving systems of equations with the two variables, I'm just going to multiply this one through by 2. Again, the reason why is because when I multiply my 2 times my negative 2z, that's going to get me a negative 4z, which will cancel with that 4z there. So I'm ready to distribute. 2z times 2z is, 2x times 2 is going to get me 4x. 2 times 3y is 6y. 2 times negative 2z is negative 4z. And 2 times negative 1 is negative 2. So far, so good. And now I'm just going to take this equation as is, but I'm going to line it up so that my x's are under my x's and my y's under my y's and my z's under my z's. So I'm looking at negative 5x. There is no y. And then I'm looking at positive 4z there. And let's just add down. So I am going to be looking at negative 1x plus 6y. And we're going to be then looking at a value of 2. So we've got this equation and we've got that equation. Well, what's the easiest thing to do? Well, in my mind, the easiest thing to do is just to add the two equations together because I've already got an x and a negative x. So I'm going to say x plus 5y, we've got there, and negative x plus 6y. All right, and let's add down. I get 11y, I get 11, so y equals 1. Awesome. I now have my y value. Just pick an equation and choose where to substitute it. So I'm going to say take this value of 1 and I'm going to substitute it in for that y there. That's my choice. You could have done another equation. You could have also probably done just as easily that equation, but I didn't. So I'm going to come back here and I'm going to say then x plus 5 times 1 equals 9. So, well, 5 times 1 is 5. Subtract 5. I'm looking at x equals a 4 there. All right, so I've now got x and y. Now, I just have to decide where I choose to substitute things. And once again, it doesn't matter. The only one I can't use to substitute is going to be this one here. Why not? Because I'm trying to find my z and there's no z in that equation. So if you're really complicated as a person, you might want to use this one because that's a more complicated equation. I've got 3 different variables and I have to solve stuff. Of course, if you're going to be smart lazy, I would say probably go to this one because you only have to substitute in 1 variable and you can fairly easily solve. So that's the way I'm going to do things. And I'm going to go with 4z minus 5x. But remember, x has a value of 4 equals 4. Okay, so 4z minus 20 equals 4. And so I'm looking at 4z equals 24, and therefore z equals 6. So my ordered triple in this case is going to get me 4, 1, 6. Now, if you're one of those people that has been watching this entire video straight through, now I would encourage you to take a break because let's face it, you've been listening to me prattle online for a very long time and you need to take a break because otherwise, yeah, your focus is going to be completely gone. The good news is I only have one more example I need to give you. So, go for a walk, do some exercise, do yoga, whatever, and then come back and we'll get us started on the last one. Okay? Next up, last one, go team. Here we go. I am looking at the following system of equations, and I'm going to say, well, wait a second, what's going to be the variable I choose to get rid of? Okay, I'm going to give you a pause and recognize which variable is the one that you want to get rid of. Waiting, waiting. I'm hoping people are noticing this one, and they're saying, there's no y. So therefore, I'm going to be combining together my other 2 equations so that I eliminate my y. Okay? And I'm going to do that by multiplying this top one through by 3, because that way I'm going to eliminate with the 3y because I get the negative 3y from those 2. And I'll be ready to roll. So let's see. 3 times 2 equals 6x. 3 times negative y is negative 3y. 3 times z is 3z. And 3 times negative 2 is a negative 6. Good so far. Now just recopy that second equation. X plus 3y minus z equals 10. And let's add down. 7x plus 2z equals 4. Okay, still good. Hopefully we're comfortable on this. Going once, going twice. Anybody with anything? Well, guess what? You're not here to ask questions, so I'm going to move on. Now, the next thing I'm going to do is I'm going to combine this equation here with this equation here. It does make me happy that these 2 are matching, but it's not perfect because in order for me to be able to do it straight up, I'm going to need to multiply this equation through by a negative 1. So I'm looking at a negative 1x minus 2z equals negative 1 times 8 is 8. So I'm ready to go. 6x, 12x equals 2. 1 down, others to go. All right, pick an equation. Which one do you think you should use? I'm going to probably go back, whoops. I'm going to go back up to here. And guess what? I am going to say that I really would like to play with this equation. So I'm going to say that x plus 2z equals a negative 8. So I'm going to say 2 plus 2z equals a negative 8. So I'm looking at 2z equals negative 10, and z equals a negative 5. All right, 2 down, 1 to go. Got to pick an equation to try and work with. Doesn't really matter. I'm probably going to be lazy enough to say that, you know what, this top one's looking pretty good to me because the y doesn't have a coefficient except for the negative sign. So let me see what I can do about plugging it into that equation. So I'm going 2 times my x value over here is still 2. So 2 times 2 minus y plus my z value is negative 5. So negative 5 equals a negative 2. All right, let's combine stuff together and see if we can get someplace. 2 times 2 is 4 minus y. 4 minus y minus 5 equals a negative 2. 4 minus 5 is a negative 1, so I'm looking at negative 1 there. And now I just need to add 1 to both sides. So that's going to get me negative y equals a negative 1. So therefore y equals 1. So now I have x is 2, y is 1, and z is a negative 5. Now, just in case anybody's curious, this is probably the hardest thing we've done in this unit. So you don't have that many problems you need to work on for Math Excel. But I would very much encourage you to work and get things done. Don't try and do it at the last possible second. Some of you might want to do the problems with a neighbor and see if they can help you. Have your calculator at the ready just in case you need to add or subtract. And I will look forward to seeing you guys next time around. Get your Math Excel done, and we'll talk later. Thanks, guys. Enjoy, or at least fake like it.